Bismillah ar-Rahman ar-Rahim. This is the second part of the introduction to modern manufacturing, and we will focus our attention in this part into the second category, which is actually the additive manufacturing technology. Okay, now let us move to the second category, which is in fact heavily now used in modern manufacturing, namely what is known as additive manufacturing. Again, please go back to your first lecture and you can see that categorization that we have made there. We have defined many categories for manufacturing. One of them was actually material removal, the second one which is subtractive manufacturing, and the second one was additive manufacturing. In fact, you have seen additive manufacturing, for instance, in the welding process, where you add material to other material and weld them together to get a product. It's a sort of additive manufacturing. But here we mean by additive manufacturing is the fabrication of processes to make engineering product parts or prototype in a minimum lead time using computer-aided design model. So the concept here is the computer-aided design model that the designer can create. So the second step after doing that is adding the material layer by layer, one layer at a time, to build the solid from the bottom to the top. As a matter of fact, when you do that, of course, the technology takes care of the form of the part precisely, and the fitting of the part with other part, and the function of the part by selecting the material. Of course, this additive manufacturing in competition with subtractive manufacturing is actually making a dramatic change in the manufacturing technology. Preparation for subtractive manufacturing using computer numerically controlled systems requires very long time for preparing the programs, and if the part is complex, in fact, it could take weeks. In additive manufacturing, the idea is rather simple. Once you have created the computer-aided design model, things could be actually start from there, and the product can be produced in much shorter time. What are the basic steps in additive manufacturing? The first and most important step is to have a computer-aided design solid model, three-dimensional model of the part. And this part, in fact, which is the virtual model, is converted into another type of file, which is known as a standard tessellation language file, which take the model, the three-dimensional model, and change it into slices, and all the information of the slices are kept in that file, and this file is transformed into a language that could be understood with the additive manufacturing machine. Then the machine is set up and the part is built in a layer by layer fashion, as we are going to see in this lecture. In fact, the part is then removed. We could have some little finishing of the part to remove the supports, for instance, or you could have finalization by painting, for instance. Let us summarize the steps. Here we start with the computer-aided design model, for instance, for this part. This is three-dimensional model, solid model. Then the second step is converting that three-dimensional model, computer model, into standard tessellation language file that could be understood by the additive manufacturing machine. And then we set up the machine. After that, we start building the product in a layer by layer fashion, and after it is finished, we can remove and we can do some little finishing like painting or removing some certain supports, and then you get your final product. Now let us focus our attention to some starting materials and layer forming technology of these materials. We have to mention in the beginning that we have wide spectrum of materials and wide spectrum of technologies used in additive manufacturing. These are very fundamental, basic, actually, examples. Starting material could be liquid polymer that are cured by laser, ultraviolet laser, and when they are cured in a layer by layer fashion, it becomes solid polymer, and this actually makes our product. The second material under consideration, it could be powder, and these powder, in fact, they aggregated and bonded layer by layer by certain adhesive bonding or synthetic binder, and here usually we use printing heads similar to that in the inkjet technology. The last one we consider is a filament of wax or thermoplastic polymer extruded into existing part surface from a work head, extrusion head, to complete each new layer. So in fact, we use the extruder head for deposition of the material layer in a layer by layer fashion. The first process we consider for additive manufacturing uses what is known as a stereolithography apparatus. The apparatus itself is very simple. We have a container, and this container is filled with liquid polymer, and then the part that is going to be built in a layer by layer fashion by additive manufacturing is built on a platform here, and the platform can move in the Z direction up and down by this simple mechanism here. So in this position here, a very thin layer of the liquid polymer is exposed to a laser beam, ultraviolet light produced by the laser beam, and this will cause the photosensitive liquid polymer to be actually become solid, and of course the beam itself from the source can move in the X and Y direction to scan a surface, the layer under consideration. So part fabrication is accomplished, in fact, in a layer by layer gradually. Once this layer is finished, we allow the platform to go down, allowing a new liquid layer, and then the layer, is actually created by the laser beam motion in the X and Y direction, and then the platform moves down a new liquid layer, and again is subjected by the source of laser beam in the X and Y direction, and we can create a new layer. So actually typical layer thickness is very small, so it could be something like 0.005 millimeter, 2.15 millimeter, and all these things are controlled by the computer. Now we consider additive manufacturing by three-dimensional printing. We have to mention here that three-dimensional printing is used in the internet and media to describe many additive manufacturing technologies, in fact, processes. But what we are going to discuss here is the original three-dimensional printing concept and idea. Part is built up using an inkjet printer, but it does not really eject ink, it ejects adhesive bonding material binder into a successive layer of powders. So binder is deposited in the areas corresponding to the cross-section of the part that was actually determined by the slicing in the tessellation stage, you remember, of the CAD geometric model into layer. This is the tessellation. So here we have a platform and we have a container. We can have a layer of the powder, and upon actually subjecting this layer of the powder to the adhesive bonding or binder, which is ejected by printing head, the layer becomes solid, in fact, with the dimensions and characteristics that describe the original slice of the part. The binder holds the powder together to form the solid part, while the unbonded powder remain loose to be removed later. Then we can create the layer here, and then layers after layer, and we can build, the body under consideration, and we get the final product here. To strengthen that part that is produced by bonding the powder together is strengthened usually by a process known as sintering step, which is applied to bond the individual powders together, particles together, and then it becomes strong. The third process, which you have seen in the lab, in fact, is known as fused deposition modeling approach. Here we have, this is a very simple process, in fact. Here we have an extrusion head here, and we have a filament, a wire like, of thermoplastic material, and then, it is actually go through the extrusion head, and it create a layer. So in this fusion deposition modeling approach, the filament of wax or thermoplastic polymer is extruded into existing part surface. Here is the platform, and it can move down to allow a new layer to be created. And in the X and Y direction, the extrusion head by the computer control system can create the layer very easily. Actually, the extrusion head moves in the X and Y, and the platform moves in the Z direction. So extrudate, the product is solidified and cold welded in 0.1 second, very quick. And then we can create the product in a layer by layer fashion. This is the one process you have seen in the lab, as a matter of fact. Now we move into a very important application of the additive manufacturing approach, namely rapid prototyping. Although in principle, rapid prototyping could be also using subtractive manufacturing approach, but in the modern manufacturing terminology, rapid manufacturing is used heavily to mean a subset of additive manufacturing to produce a product that resembles the physical model of the part under consideration, to allow the designer to see and feel and can actually judge, should I improve the geometry, should I actually think of making any alteration or modification, or detect any error in the design, increase capability to compute mass properties, etc., etc., etc. Here, for instance, this actually architecture engineer can actually see the prototype of the building he has actually designed to see the merits, and so on and so on. So rapid prototyping is very important, in fact, before going into mass production, to feel, in real sense, the product and the physical model, how it looks, and the properties of that. This is known as prototype. So, can we make rapid prototyping only by additive manufacturing? No, I said. You can do it either ways. You can do it by material removal. So this is known as CNC, rapid prototyping, which is very common. In fact, it has been used very long time, and it is now still used, especially in creating dies and these kind of things. But now, to make rapid prototyping model, the first model, usually it can be built from soft material like wax. Before you go into building the real one using tool steel, for instance, you create a rapid prototype very quickly by this, and you can examine, and if you feel okay, you can go to the real production by CNC approach, for instance. But in additive manufacturing, as we mentioned, we add layer by layer of material one at a time to build the solid part from bottom to top. As a matter of fact, this gives us more advantage than the CNC rapid prototyping. Here, it is very quick speed of part. I don't need to build a whole program to create the CNC part. Avoidance of the CNC part programming task is very important issue, because this actually CAD model that we created for the part is what we need in additive manufacturing. Then it goes automatically to the distillation and creation of the part. The complexity of the part geometry is not an issue in additive manufacturing, but in subtractive manufacturing, no, it is a very important issue. Sometimes the part could be complicated, such as the programming for that is completely difficult or sometimes impossible. So in that case, we can overcome this, geometry problem in additive manufacturing. A very big advantage, in fact. Let us have some example. We will actually apply rapid prototyping to make tools. And in that case, it is known as rapid tool application. Here we have two examples, both in casting, but it can be used in other applications here. Here, for instance, we have 3D printing casting pattern here. And this pattern could be used to create casting by casting process. Here, for instance, we have, a mold. The mold itself has been created by 3D printing. And in that case, from powder, metal powder, we can create 3D printing, die, and we allow this to be sintered, as I said before, by heating. It becomes very strong. And in that case, it can be used for direct production. The first one is indirect rapid tool making, because this is a pattern, just a pattern. It is not, going to be used to be directly as a die or as a mold. But here we create the die or the mold directly, and this could be used for the fabrication of the tool under consideration. So what other applications of additive manufacturing? Many other applications are advantageous for additive manufacturing, in fact. Small patches of plastic part that could not be economically molded by injection molding, for instance, because of the high cost of the mold. Although the injection molding approach could produce beautiful product, complicated product, and so on, but it is very expensive to create the die for that product. Here, creating parts like this in a layer by layer is very simple. The parts with intricate geometry also could be made without difficulty. As a matter of fact, you don't need to make assembly. You create the whole part, one piece. Complicated part, you create it as one piece. You don't need to make 2-3 parts and assemble them as in conventional manufacturing approach. This is very important also to make spare parts, where you need, some spare part with very limited number, few number, 2, 3, 4 pieces only. So in that case, the additive manufacturing, once you have the computer-aided design model of the part, you can make actually a small number of parts economically without difficulty. Also, one-of-a-kind parts such as bone replacement. This is very important application. When somebody need a hip replacement, for instance, or a bone in the shoulder replacement, or in the arm, or and so on and so on, in that case, it has to be designed specifically for that part, for that person. It is actually one-of-a-kind part, for the correct size. Now there is no problem to do that using additive manufacturing. As a matter of fact, the application of additive manufacturing is very, very, very wide. In last year, they faced the dilemma of this COVID-19 pandemic, in fact, and it was no difficulty, in fact, to create valves like this that is specific for certain application with certain dimension and to be used with the mask using three-dimensional technology. But we have actually plenty of applications of additive manufacturing. Look at these actually images here. You can actually tell about the applications in a complete whole course. In fact, it needs long time. So interested person could go to the area of application on the internet and see more detail. In fact, I invite you to do that. You will be excited with the tremendous applications of additive manufacturing in aerospace engineering, in dental engineering, for instance, in medical applications to create certain parts for dental surgery, and of course in jewelry you can create very, very fancy and sophisticated jewelry using 3D printing approaches or additive manufacturing techniques, and so on in electronics, and so on in toys for kids, and in textile industry, and so on and so on and so on. As a matter of fact, the potential of the industry using additive manufacturing is tremendous, and it is currently spreading and expanding very fast, very, very, very fast. As I mentioned, this is actually the new manufacturing revolutions, to use additive manufacturing in manufacturing engineering. This gives the engineer complete spectrum of applications to make parts that were rather difficult to produce otherwise before. The references and links used in the preparation of this presentation, the two parts of the presentation, in fact, are shown here, in addition to many useful links as shown hereafter. And these are some useful links. I invite you to go, and these links have been used as a source for many of the figures you have seen in this lecture, and I invite you actually to go and visit these actually sites. You will be impressed with actually the applications. Okay. Thank you very much.